recording here in the machine shop, and I've got Dominic Figueroa here, and he's going to tell us all about his machines. Dominic, take it away.
Very good. All right, so this is the machine lab. We have, most of our machines in here are fairly dangerous, so we don't just leave it open. I'm going to start over here with something that most people will understand. This is just a bandsaw. It's really made for wood. It's not really made for metal. I have specific saws that are made for metal. But we do have this in here. All of the machines in here will always have an emergency stop, because I'm all about safety in here. Generally, anytime anybody comes in here, they have to have glasses, and I'll show you where I keep those in just a minute. But so basically, this has an emergency stop on it. It has a band that goes through it. It's made for soft materials like wood, and maybe some hard foam, but never metal, because it's really not made for that. Over here we have a basic drill press. All these machines are super powerful, so you always have to be very cautious. And one thing in here is we never work alone. You always have to have somebody with you when you're working, just in case something happens. So again, you'll see, I call it the big red clown nose on here. This is the emergency stop button. If I wanted to run this, I would turn that. The emergency stop button pops open. I set my speed. We always go in forward, not reverse. So I would set it for forward, and then I'd press play. It takes a second, and now the machine starts. And you can see it's running fairly slowly, but we could adjust that to whatever we need to do. And then to stop it, I hit the emergency stop button, and it stops.
Is that how you're supposed to stop it, or are you
Yep.
supposed to use the little switch on the side that says 0 or 1?
Nope.
Okay.
Yep. So we always stop it that way. So this is a manual lathe. So a manual lathe, the way I would describe a lathe to somebody who's never used one is it's almost like a glorified pencil sharpener. We have the chuck here. It's a 3-jaw chuck, mainly because we use cylindrical materials in here. I can set the speed and the feed rate. I can run this manually. It has 2 axes. It has a Z axis and it has an X axis. And I can run those manually like so, or like so. And I could also run them automatically. This machine is very safe as long as you use it properly, but if you don't, it can be extremely dangerous. So I have many safety features on here. When this is open, it shuts the machine down. The only way you can use it is to close it all the way down. If there's ever a problem down at the bottom, I have an emergency brake. All I have to do is hit it. It stops it immediately. And then I can make this thing automatically move in the positive or negative Z position, or I can make it move in the X position also automatically. Up here, this is called a digital readout, or a DRO. What this does is it allows me to have much more precision. It'll give me numbers in imperial numbers. We always use imperial numbers in here. Down to 4 decimal places or 1/10. So 0.0001 is 1/10. And just to give you an idea of what that means, a human hair is 3/1000ths of an inch across in diameter. If I cut a hair into 3 parts, each one of those parts is 1/1000th. If I cut one of those into 10 parts, one of those is called a 10th. So that's a 4th decimal place. It's microscopic, you can't see it, but this can show me that I have moved in that much of an increment. Next over here we have
Dominic, is that what they call a micron?
It's actually, it's very close, yeah.
Very cool. Very cool.
And then over here we have our CNC router. It's a computer numeric controlled router. It's an older machine. I don't use it that much. But basically, if I wanted to come up with a new idea for a guitar body, because I teach a guitar class here also that's very, very popular, I can try out my tool path on something that's inexpensive before I end up destroying a beautiful piece of mahogany or oak or something like that.
Gotcha.
We generally don't use this in here because it throws a lot of dust, and the dust will destroy most of the computers, which it has in the past. So I just have it here because it's kind of a cool machine. This is a very famous machine. This is a manual mill, so a milling machine. And basically milling machines will create any kind of a flat surface to near perfection, which is why they used to use these in the war, and that's how Bridgeport machines, the Bridgeport machine, the Bridgeport mill is one of the most famous mills ever because of its precision. So with this, I can use it as a drill press, or if I was using it as a mill, I want a lot more accuracy than that. So instead of dropping this down, if I had a tool in it, I would actually lift and lower the table with these knobs here. So this would be my Z-axis, would bring this up and down. This right here would be my X-axis, my Y-axis, and this is my X-axis right here. I can also have this machine set up to do in the X-axis in automatic mode, but in general we don't do that in here because then things get dangerous if somebody's not paying attention. Again, this is the digital readout, and this gives me down 4 decimal places. So if I was gonna tell you what this number meant, or you were talking to a fellow in the shop, it's 0.8016, you would say it's 801 thousandths and 6/10. So our language in here is a bit different than what you would normally hear unless you were in a shop dealing with the people who are actually doing the manufacturing. And we talk a lot about our language in here. Our next tool over here, this is a CNC machine, and again, it's a computer numeric controlled milling machine. These machines are not made for just doing one part. Generally, we use these machines for making thousands and thousands of parts with very precision tolerances, like maybe they have to all be within 3 thousandths or the diameter of a hair different in order to pass inspection. So the reason we don't just throw one part in here is because just to program it takes a tremendous amount of time, and then we have to proof it, which means it'll give me something on the screen which will look like the part to let me know if it's kind of doing what I want it to do. And then we would run the actual program above the part to make sure it doesn't crash or do anything that we weren't expecting. And then finally, we'd very carefully make it go through the program on the part, one step at a time, just to make sure that it doesn't damage the machine or break the tools or hurt anybody, because it certainly can. But this machine can hold the tolerance of 2/10. So what I said, one human hair is 3 thousandths. One of these sliced up into 10 parts, and if you took 2 of those little parts, that would be 2/10. It's microscopic, but the machine tracks that. So you can't actually see it. Like if you put a cup of water on that and you moved it 2 or 3 or 10 tenths, you would not see any ripples in the water whatsoever. But the machine keeps track of that, so it's made for super accuracy. So over here, this is a CNC lathe, computer numeric control lathe, just like the manual one I showed you earlier, but it's all computer numeric controlled. So every single movement that this machine makes has to be programmed in. So it's a lot of work to program a machine to do it accurately. And then you have to, like I said, test out your program just to make sure that it's doing what you want and find where it might be. You'll get fault errors, so it won't tell you exactly where the problem is. It'll just say there's a problem. And if you're using CNC code, which is X and Y, which is G and M code, it's called. So M code would be to turn things on and off. The G code is all your coordinates. So every single step of that program has to be programmed in. So it's a tremendous amount of work. And that's why we don't just use it for any old thing that we want to throw in there. But if we wanted to make 10,000 of the exact same parts, then it's worth going through all that process to get it down to where it actually works consistently. This actually is just something that we manufactured a while back with a student of mine for a senior project. And it was actually supposed to be made for spraying, hornets' nests up in the trees and so forth. And so I just kind of kept it.
Does it fly?
I haven't tried it. They tried to fly it a few times, and they ended up flying it into the side of the building, but it probably would, yeah. So back here, we have our metal cutting machine. So this is a liquid cooled chop saw. It goes very slowly. It has a clamp here which keeps it nice and safe. You clamp your material in there. Has an emergency on and off. And then you just press play. It's liquid cooled, so the liquid will start going over the blade. And it's really, again, made for soft materials, brass, cold rolled steel, aluminum, things like that. If we had anything that was really hardened steel, we'd have to use a cold saw, which we don't have in here, but there is one downstairs. And then right over here, this is a liquid-cooled bandsaw. It's hydraulic, and so it's basically kind of the same idea, but it can handle larger pieces of material. But again, it's not made for really hardened steel. I've had people come in and ruin the blade already just because they tried to put something that was hardened in there, and it just destroys the blade. But for softer materials, it works very, very well. Really safe. Always have to have the clown nose here for emergencies. And it comes down as slow or as fast as you want. And you can actually see the coolant right up in here. It's usually blue. And that just keeps the blade lubricated so it doesn't heat up, and so it keeps a nice sharp edge. This is our 60-watt universal laser. I actually got this for my guitar class that I teach. We do some laser work on the guitars, which is really cool. It has a nice big bed. The bed is 18 by 32 inches, so it gives you a lot of space to work. This is actually, so the thing about lasers, this is cast acrylic. In this machine, we have to be very careful what materials we put in there. So as far as plastics go, we only use cast acrylic. We can use woods. So with the wood, what we have to be careful of is a fire, because you have a very hot laser cutting through wood, and there's air blowing on it to keep those little particles off of the lens, and it could very easily start a fire. So each time we do something different in the laser, we have to figure out what the prescription is that we want, or the recipe for that particular type of material. This is cast acrylic, and it's a very nice plastic to cut in lasers. Generally, that's what you should use in a laser, because if you use the wrong material, it can kill you. If you tried to cut ABS, it creates cyanide, which obviously, will kill you. If you were to use PVC, it will create chlorine gas, which will kill you. So we're very cautious as far as like what we put in here, and of course, it's never left alone while it's working. Somebody always has to be monitoring it, because it's a very safe machine as long as you do it right, but if you do something wrong, it could catch fire. When we use it, we always turn our vent on. We have a vent down there that goes right out there, and then we turn on some air, which actually just has a little hose that blows the dust off of the lens. But it's a great machine. We use it quite often. Over here we have our safety goggles. So this came in really handy, especially with COVID. So anytime a student comes in, they get their safety glasses. When they're done, I close it. And then I just turn this on for 15 minutes. And it's the light actually sanitizes everything, so that next time somebody comes in, they can just use it without worrying about germs or who happened to wear it beforehand. We have a lot of measuring tools in here. This is just a piece of precision ground granite. Costs quite a bit of money because it's perfectly ground. And this is almost like a vernier caliper upside down, and it's called a height gauge. So if I wanted to measure something with precision, I would use this like the screen of the vernier caliper. I would lift it up to the area on the part that I wanted to make a mark. We would stain the material first, and then I would this has a carbide edge here, and I would just take one little sharp edge of it, and I would slide it across the material, and it'll just leave a beautiful line in the material through the stain that we use called Dicam. It comes in dark red and dark blue. And it just gives you a very crisp, clear target for drilling or whatever it had to be with great accuracy. So that's pretty much it. We do have fun in here, but I'm pretty strict as far as, we don't goof around too much because the machines are dangerous, and I really watch everybody very, very closely. As everybody knows, I'm very much in favor of safety. That's my main thing in here. So great. Hope this helps, and feel free to come by and chat anytime about any ideas you may have. Okay?
Thanks a bunch, Dominic.
You got it. Thank you.